Sorry. Hi again, everybody. This is Professor Sebastian. Welcome back to our statistics class notes. We're on page 72, and briefly on the last page, we were talking about, in theory, what would happen rolling a one-sided die. So on one six-sided die, how you would get the probability of rolling a 1 would be 1/6, the probability of rolling a 2 would be 1/6, probability of rolling a 3 would be 1/6, etc., since they're all equally likely. Okay, so we're going to actually go ahead and play with StatCrunch a little bit and see what happens when we see what actually happens randomly when we're rolling a die. So the way we can do that is we're opening StatCrunch, and we're going to go to Applets, StatCrunch Applets. Again, you don't really need to do any of this, but I'm just playing with it to show you. Simulation, and we're going to go to dice rolling. Okay, and we're going to let the number of sides on the die be 6, and the number of dice to roll be 1. And we're going to select display sum of the rolls and click compute. So we're going to display sum, and we're going to hit compute. And let's see what happened there. Notice that we got, oh shoot. Okay, so now I'm going to select, now I'm going to select one run, okay, and we got a 5. So we got a 5, and on that first roll there on page 72, we're going to put in number 5. And then we're going to go ahead and roll it 5 more times. So I'm going to roll it 5 runs, do 5 runs real quick. And we're going to, we'll do all short here. We'll do one more run, and I got a 2 this time. On the second roll, I got a 2, so I'm putting that in on right here on page 72. And then the third roll, I got another 5. And on the fourth roll, I got a 3. And then I'm clicking roll one more run again. On the fifth roll, I got a 2. And on the sixth roll, I got, what happened? 6. Okay, so did we get the numbers 1 through 6 exactly once? Absolutely not, right? That's not how it would work randomly. So looking at our sample space of 6 single rolls, did you have the same probability of getting a 1, 2, 3, 4, 5, or 6 as was indicated by the classical or the theoretical probabilities? Certainly we did not. Notice that when I write down the empirical probability, the probability of 1 here in the middle of page 72, well, we got no ones. So that's 0 out of 6, which is 0. The probability of 2, we got 2 2s, so that's 2 out of 6 rolls, which is a third. Probability of getting a 3, we did get 1 3 only, so 1 out of 6, which is, of course, 1/6, which is exactly what we would expect to get. Probability of 4, we got no 4s, so 0 out of 6, which is 0. The probability of a 5, we got 2 5s, so 2 out of 6, which is 1/3. And the probability of getting a 6, we got 1/6, so 1 out of 6. Of course, 1/6. Okay, so now I'm going to go ahead and simulate rolling it basically 3,000 times. I'm going to just add 3,000 times to this doing one roll. So when I click at 3,000, or I'm going to click 1,000 once, that pretended to roll the die 1,000 times. You can see total of 1,006 here. I'm going to click it again, and I'm going to click it again. Okay, so technically I've rolled it 3,006 times. So now I'm going to look at that, and I'm going to look at how much each one of these was. So I'm going to put the sum of one roll equals 1. And you can see those. Okay, and it tells you how many of our 3,006 rolls we got. We got 481. Out of our 3,006 rolls, we rolled a 1. Okay, is it close to 1/6, which is 0.167? Pretty close. So I'm going to check all of these. So sum of run roll was, the proportion was 0.16. Write that down there in that last table at the bottom of page 72. I'm going to change this to a 2. See how many 2s we got. We got 453 out of 3006, which is 0.1507. And you can see that that's, this bar is less high than the ones were, right? We had 481 here and 453 here. Okay, roll. How many did I get a 3 on? I got 529 out of 3006, which is 0.176. Let's see, 4. I got 505 times, which is 0.168. I'm just taking 505 divided by 3006, 0.168 or 16.8%. That one's really close to 1/6. Let's see, 5s. I got 522 out of 1, so 0.1737. And then the 6s, how many of those did I get? 516 out of 3006, which is 0.1717. So are the values in the table above relatively close? They're all pretty close, but you can see that they didn't get exactly. So out of 3,000 runs, it wasn't 1/6, 1/6, 1/6, 1/6, 1/6, 1/6. I mean, we're going to have to keep going and going and going to get each one of these closer to 1/6. The only way they actually get to be 1/6 is if you go all the way to infinity, which of course we can't. All right, but that's how this works, okay? So this would be like doing an empirical probability. Theoretically, we know that each one of these should have a 1/6 probability of coming up. But when I rolled the dice 3,006 times, they all got close to about 1/6 of the time, but they weren't exactly.